At the beginning of March 1944, Japanese coastal radar posts detected a group of aerial targets moving toward the islands from the direction of the Yellow Sea. The log entry recorded the time of detection, bearing, and an altitude notation that exceeded standard parameters for known aircraft types. In accordance with established procedure, the signal was transmitted to the Sector Control Center. Several minutes later, an alert was declared at the airfields. Takeoff records indicate that fighter aircraft became airborne in compliance with the order. Flight logs recorded the time the climb began and the engine power settings used. Radio traffic reflects course corrections and new commands for further ascent. Subsequent entries appear only after the aircraft returned to base. The reports contain no entries indicating contact. In the results column, a standard notation is recorded. Ground observers reported aircraft passing high above the cloud layer. Anti-aircraft unit logs contain no record of opening fire. Municipal services recorded the fall of bombs. In the late 1930s and early 1940s, industrial data collected by German military and economic intelligence services increasingly included references to manufacturing activity in the United States that exceeded earlier estimates. Reports compiled by the Abwehr, by economic sections of the Wehrmacht High Command, and by German commercial observers stationed abroad recorded developments in American aviation production that required continuous revision of pre-war assumptions. Among the firms monitored with particular attention was the Ford Motor Company, whose facilities, labor organization, and output figures were repeatedly noted in memoranda circulated within German intelligence channels. By 1940, Ford Motor Company had been identified in German files not only as an automobile manufacturer but as an industrial enterprise capable of rapid conversion to aircraft production. Prior to the formal entry of the United States into the war, German analysts collected open-source material, trade publications, patent filings, and observations from neutral intermediaries concerning Ford's machine tooling, assembly line practices, and labor discipline. Reports noted that Ford's existing plants employed conveyor-based production systems, subdivided tasks into narrowly defined operations, and relied on standardized components produced at scale. These observations were logged without speculation, forming part of routine industrial intelligence summaries distributed to military procurement offices. In early 1941, German economic intelligence summaries referenced American government contracts with private manufacturers for aircraft production. The Consolidated Aircraft Corporation's B-24 Liberator bomber was listed among aircraft types ordered in large numbers. Subsequent documents recorded that Ford Motor Company had received authorization to construct a dedicated plant for B-24 production near Ypsilanti, Michigan. The site, later identified in reports as Willow Run, was described in technical terms, including land area, proximity to rail lines, and access to electrical power. Intelligence assessments tracked the progress of construction through aerial photographs obtained indirectly and through commercial satellite imagery descriptions acquired from neutral aviation publications. Construction reports from mid-1941 detailed that the Willow Run plant was being erected using reinforced concrete and steel framing, with roof spans exceeding those typical of automobile factories. German observers noted that the building layout appeared optimized for linear flow rather than batch assembly. Documents filed by German attaches in neutral countries referenced American press releases describing the plant as a single continuous assembly line extending more than a mile in length. These references were transcribed into intelligence digests without commentary. By late 1941, as the United States formally entered the war, German intelligence reporting on American industrial capacity intensified. New directives from Berlin instructed collection agencies to prioritize information on aircraft production rates, workforce size, subcontractor networks, and component standardization. Ford Motor Company was designated a priority target for industrial intelligence collection due to its scale and reputation for production efficiency. In early 1942, reports compiled from shipping manifests, labor statistics, and American government announcements indicated that Ford had begun tooling the Willow Run facility for bomber production. German intelligence summaries listed the number of machine tools installed, including milling machines, presses, and riveting equipment. Observers noted the delivery of specialized jigs and fixtures designed for airframe assembly. These details were collated into technical annexes circulated among German procurement planners. German intelligence analysts recorded that the B-24 bomber consisted of approximately 1.5 million individual parts, including structural components, fasteners, electrical wiring, hydraulic systems, and armament fittings. This figure appeared in multiple reports, derived from American technical manuals and procurement documents. The complexity of assembling such an aircraft was noted in descriptive terms, with enumerations of subsystems and production stages, without evaluative language. By mid-1942, reports from German agents operating in neutral countries cited American press statements indicating that Ford aimed to produce bombers at an unprecedented rate. Initial production figures recorded low output, with assembly times measured in days rather than hours. German intelligence summaries tracked these figures month by month, noting incremental reductions in assembly time as workforce training progressed and supply chains stabilized. Documents dated late 1942 recorded that Ford's workforce at Willow Run had expanded to tens of thousands of employees, including skilled machinists, semi-skilled assemblers, and administrative staff. Reports listed workforce composition by gender and age, reflecting American labor mobilization practices. German intelligence noted the establishment of training programs to standardize assembly procedures and reduce variation. These observations were filed as factual entries in labor and production reports. Throughout 1943, German intelligence agencies continued to monitor production data related to Willow Run. Reports referenced American government publications stating monthly output targets and achieved figures. Internal German summaries noted that production delays had occurred due to design changes, supply shortages, and quality control issues. These issues were recorded in chronological order, based on available documentation, without inference regarding long-term outcomes. By mid-1943, intelligence reports recorded a significant increase in output at Willow Run. Documents cited American sources stating that assembly time per aircraft had been reduced substantially. German analysts compiled tables showing reductions in labor hours per bomber and increases in daily production rates. These tables were appended to intelligence briefs circulated among Luftwaffe logistics planners. In the autumn of 1943, multiple German intelligence reports independently recorded claims that Ford's Willow Run plant had achieved an assembly interval approaching one completed B-24 bomber per hour. One report, dated October 1943, cited an American industrial journal stating that under optimal conditions, an aircraft left the final assembly line approximately every 63 minutes. This figure was transcribed verbatim into German intelligence summaries and distributed without modification. Subsequent reports sought to verify this figure through cross-referencing additional sources. Shipping records from American ports indicated increased outbound deliveries of completed aircraft. Rail transport schedules showed frequent movement of large aircraft components from subcontractors to Willow Run. German intelligence summaries correlated these logistical data with reported assembly intervals, noting consistency across sources. Technical annexes accompanying these reports described the organizational structure of the Willow Run assembly line. According to compiled descriptions, the production process was divided into sequential stations, each responsible for a specific set of tasks. Components arrived prefabricated and pre-inspected from a network of subcontractors distributed across the United States. German intelligence documents listed categories of suppliers, including aluminum producers, engine manufacturers, and electronics firms, with estimated delivery volumes. Reports also detailed quality control procedures observed or inferred from American documentation. Inspection stations were noted at multiple points along the assembly line. German intelligence summaries included descriptions of standardized measurement tools, tolerance specifications, and documentation protocols used to track compliance. These descriptions were included as factual accounts of observed practices. By early 1944, intelligence reports from multiple German agencies referenced the 63-minute assembly interval as an established figure in American industrial reporting. Documents circulated within the German High Command included statistical tables listing estimated annual output from Willow Run based on this interval. These tables were presented as calculations derived from reported data, without commentary. German intelligence also recorded information on workforce shifts and operating schedules. Reports indicated that Willow Run operated around the clock, with multiple shifts per day. Energy consumption figures were cited, based on American utility reports, indicating high electrical load consistent with continuous operation. These figures were incorporated into assessments of industrial activity levels. In parallel, German intelligence monitored American public communications regarding aircraft production. Press releases, speeches by American officials, and factory tour descriptions were collected and translated. References to Ford's production achievements were extracted and summarized. Intelligence analysts noted the use of standardized language across multiple sources, suggesting coordinated information dissemination. These observations were recorded without further elaboration. Reports also included descriptions of physical plant dimensions. The Willow Run facility was described as covering several million square feet, with internal transport systems including conveyors and overhead cranes. German intelligence documents listed measurements and capacities as reported in American engineering publications. These technical details were compiled into reference files. Throughout this period, German intelligence agencies maintained files on Ford Motor Company's leadership and management structure. Names of executives, plant managers, and production engineers were listed, along with their professional backgrounds. These entries were factual, derived from publicly available information, and updated as personnel changes occurred. German intelligence summaries also recorded American government oversight of aircraft production. References were made to the War Production Board and to inspection teams assigned to Willow Run. Reports listed regulatory requirements and reporting obligations imposed on the plant. These details were included to contextualize production data. By mid-1944, German intelligence reports continued to cite the 63-minute assembly interval as part of routine production statistics. No revisions to this figure were recorded in available summaries during this period. Reports focused on tracking output volume, delivery schedules, and deployment of completed aircraft to operational units. Throughout all reporting, German intelligence documents maintained a consistent format, presenting data in chronological order with source citations where available. Language remained descriptive and procedural, reflecting the conventions of military intelligence reporting. Observations regarding Ford's production methods, workforce organization, and output rates were recorded as discrete entries, without evaluative statements or interpretive conclusions. As the war continued, intelligence collection on American industrial production persisted, with Ford Motor Company remaining a recurring subject in reports. The Willow Run plant's reported ability to produce a complex bomber aircraft at intervals measured in minutes was documented alongside other industrial data, forming part of the broader body of wartime intelligence records maintained by German agencies during this period. From April 1945, Japanese Air Defense Headquarters continued to issue daily operational instructions based on accumulated experience from previous months. These instructions were distributed through established command channels and recorded in unit order books. They specified readiness levels, scramble procedures, and altitude assignments corresponding to expected bomber approaches. Radar station logs from this period show near-daily detections of incoming formations, with estimated altitudes frequently recorded above 30,000 feet. The detection data were passed to sector control centers, where plotting boards tracked bomber movement across assigned zones. Time stamps indicate that the interval between initial detection and fighter scramble orders often ranged from several minutes to over 10 minutes, depending on communication flow and confirmation requirements. Fighter readiness reports compiled each morning listed aircraft availability, pilot status, fuel stocks, and ammunition reserves. These reports were standardized forms forwarded to regional commands. Entries frequently noted reduced serviceability rates due to engine wear, landing gear fatigue, and shortages of replacement components. Maintenance units recorded extended turnaround times between sorties, particularly for aircraft that had conducted high-altitude climbs. Engine inspection logs document instances of overheating, oil pressure fluctuations, and supercharger failures following such missions. Climb performance remained a primary factor recorded in sortie reports. Pilots' debriefing forms included fields for time to reach assigned altitude, engine settings used, and oxygen system performance. Many entries note that reaching assigned altitude required sustained maximum power, with climb rates diminishing sharply above certain thresholds specific to each aircraft type. Oxygen equipment logs show recurring issues with regulator malfunction and mask seal integrity at high altitude. Ground crews documented repairs and adjustments made between sorties. Airfield operations records indicate that scramble procedures were affected by runway congestion and dispersal practices. To mitigate bombing damage, aircraft were often parked in revetments or dispersed areas, increasing taxi time to the runway. Scramble timing sheets show that the interval between alarm and takeoff varied accordingly. These intervals were logged and reviewed by base operations officers, with notes on causes of delay such as mechanical checks or congestion. Intelligence summaries prepared by Army and Navy staff sections described bomber formation characteristics observed during recent raids. These summaries included estimated formation size, spacing, altitude, and defensive fire patterns. They were based on pilot observations, ground reports, and occasional recovered fragments. The summaries were circulated as reference material and appended to operational orders. They did not include analytical conclusions but listed observed parameters in tabular form. During daylight raids, visual acquisition remained difficult due to altitude separation. Pilot reports frequently note sighting contrails at distances that did not permit interception before bomb release. Contrail observation logs kept by ground observer units recorded direction, altitude estimate, and duration of visibility. These logs were correlated with radar tracks and included in regional situation reports. Escort fighters accompanying bomber formations were also noted in air defense records. Radar operators occasionally detected additional contacts at lower altitudes or different speeds. Pilot debriefings mention encounters with escort aircraft during climb or withdrawal phases. Engagement reports list brief contacts, firing attempts, and disengagements. These entries are factual and limited to time, location, and observed actions. Fuel consumption records continued to influence interception outcomes. Mission planning sheets calculated expected fuel burn for climb, interception attempt, and return. Actual fuel remaining upon landing was recorded in pilot logs. Many entries show minimal reserve margins, leading to abbreviated engagements or early disengagements. Fuel storage reports document ongoing limitations in supply, with priority allocation specified by command directives. Night operations expanded as bomber tactics diversified. Night fighter unit diaries record sorties launched based on radar or sound detection. Ground-controlled interception procedures were documented in training circulars and applied operationally. Logs show that maintaining radar contact with high-altitude targets at night was inconsistent. Pilots' night debriefings often record loss of contact during climb or difficulty aligning interception vectors. Searchlight unit records from urban defense zones document attempts to illuminate bombers. These logs include beam elevation angles, duration of illumination, and coordination with fighter units. Many entries note maximum elevation limits being reached without sustained contact. Coordination reports between searchlight units and fighter control centers describe communication attempts and timing discrepancies. Weather remained a constant variable in operational records. Upper air weather reports issued by meteorological units were attached to daily air defense briefings. These reports detailed wind speed, direction, temperature, and cloud layers at various altitudes. Fighter units reference these reports in planning climb profiles. Pilot debriefings note turbulence, icing, and wind drift encountered during ascent. Such observations were logged and forwarded to meteorological sections. Aircraft armament records show continued emphasis on heavy-caliber weapons for high-altitude interception. Modification orders authorize the installation of larger cannons or upward-firing guns on certain aircraft types. Installation logs record completion dates and test firings. Combat reports from modified aircraft include entries on firing attempts and ammunition expenditure. Weapon maintenance logs document recoil damage and feed issues under operational conditions. Coordination between different air defense sectors was governed by boundary agreements recorded in command manuals. Situation reports note instances where bomber formations crossed sector boundaries during climb phases, complicating handover of control. Fighter units sometimes received updated vectors mid-climb, as recorded in radio logs. These adjustments are noted with timestamps and frequency usage. Civil defense observation reports continued to provide supplementary data. These reports were compiled from factory watch units, police posts, and volunteer observers. They recorded bomber passage, altitude estimates, and audible engine noise. The reports were standardized and submitted after each raid. Many entries indicate the passage of bombers without observed interception overhead. Training directives issued during this period reflect ongoing efforts to adapt procedures. Circulars instructed pilots on optimized climb techniques, engine management, and interception geometry. Training sortie records show limited implementation due to fuel constraints. Where training flights occurred, results were logged and evaluated in brief memoranda. Loss records for fighter units document aircraft destroyed or damaged during interception attempts. Causes listed include combat damage, engine failure at altitude, and landing accidents following fuel depletion. Personnel records note pilot injuries or fatalities associated with these incidents. Replacement aircraft and personnel assignments are recorded with dates, showing gaps between losses and replenishment. Command communications preserved in message logs show repeated requests for improved equipment, fuel, and radar coverage. Responses from higher headquarters are recorded as acknowledgments or directives. These exchanges are factual and procedural, reflecting the administrative flow of information. By May 1945, air defense engagement summaries show continued attempts to intercept high-altitude bombers with limited contact rates. Tables list numbers of bombers detected, fighters scrambled, fighters reaching assigned altitude, and engagements reported. These summaries were compiled daily and forwarded to central commands. Throughout this period, documentation practices remained consistent. Each action was recorded in prescribed formats, using established terminology. The accumulation of logs, reports, and orders from this phase provides a continuous account of air defense operations as conducted, reflecting the constraints and procedures documented at the time, without alteration or expansion beyond the recorded entries. From May 1945 onward, Japanese air defense organizations continued to operate under standing orders that emphasized immediate response to radar contact and visual confirmation. Daily operational schedules issued by regional air defense headquarters specified alert conditions, crew assignments, and aircraft readiness states. These schedules were logged and signed by duty officers. Radar station activity logs from this period show frequent equipment outages due to power interruptions, component failure, and damage from earlier air attacks. Maintenance entries note improvised repairs and reduced detection ranges during such periods. When stations were operational, operators recorded multiple contacts approaching from varying bearings, often at altitudes estimated beyond the effective interception ceiling of many assigned fighters. The reporting chain from radar station to fighter unit remained unchanged. Initial contact reports were transmitted to sector control, where plotting officers updated situation boards. Fighter scramble orders were issued according to predefined thresholds of certainty. Communication logs indicate that confirmation delays persisted, particularly when radar returns were intermittent or overlapped. These delays were noted in message registers with brief annotations indicating cause, such as signal fade or conflicting reports from adjacent stations. Fighter units continued to operate mixed inventories of aircraft. Unit strength returns submitted weekly list aircraft by type and status. Serviceability rates fluctuated daily. Maintenance logs show repeated grounding of aircraft due to engine wear aggravated by continuous high-power climbs. Supercharger maintenance entries increased in frequency, noting seal degradation and bearing failure. Aircraft awaiting parts were listed as non-operational, with estimated repair times often left blank due to supply uncertainty. Pilot assignment rosters indicate that many experienced pilots were retained for home defense roles. Flight logs from these pilots document repeated high-altitude sorties with limited contact. Each sortie entry includes takeoff time, climb duration, maximum altitude reached, and landing time. Remarks sections frequently note inability to reach assigned altitude before bomber passage. These remarks were recorded without elaboration. Fuel distribution continued to constrain operations. Depot inventory reports show declining reserves of aviation gasoline. Allocation directives from higher command specified daily sortie limits per unit. These limits were recorded in unit order books. Pilots' flight logs reflect adherence to these limits, with some days showing no sorties flown despite radar contact reports. Such instances are documented as "no launch due to fuel restriction" in daily activity summaries. The introduction of emergency measures was recorded in command circulars. These measures included shortened engine warm-up procedures, reduced formation sizes for interception, and authorization for single aircraft launches when formation assembly would cause delay. Implementation of these measures is reflected in sortie records showing increased single aircraft scrambles. Debriefing forms from these sorties record similar outcomes to previous operations, with altitude limitations noted. Bomber operational patterns were continuously logged by intelligence sections. Summaries compiled from radar plots and observer reports describe variations in approach routes, altitudes, and timing. These summaries were distributed internally and appended to daily briefings. They list observed data points without interpretive commentary. Fighter control officers referenced these summaries when assigning patrol zones and interception points. Airfield vulnerability affected operations. Engineering reports document damage to runways, taxiways, and fuel storage areas from air attacks. Temporary repairs were logged, including use of fill material and steel mats. These repairs often limited aircraft weight at takeoff, affecting climb performance. Takeoff weight restrictions are noted in operations logs and were factored into mission planning sheets. High-altitude physiological strain on pilots was recorded in medical logs. Flight surgeons submitted reports on hypoxia symptoms observed after sorties. These reports list symptoms, duration, and recovery time. Recommendations included stricter monitoring of oxygen equipment and reduced sortie frequency. These recommendations were circulated, but implementation was constrained by operational demands. Oxygen system supply records show shortages of replacement bottles and regulators. Maintenance sections logged cannibalization of equipment from grounded aircraft. Pilots' debriefings occasionally note oxygen flow irregularities during climb. Such notes were included in standardized forms and forwarded to technical officers. Interception geometry continued to be a focus of procedural documentation. Training memoranda outlined preferred attack angles and timing for high-altitude targets. These memoranda referenced performance charts included as appendices. Operational application is reflected in engagement reports describing attempted head-on or climbing attacks. Outcomes were recorded as approach distances and firing opportunities, often noted as no firing due to position. Defensive fire from bombers was recorded in pilot reports. Entries list observed tracer density and approximate range. No evaluative statements were included. Aircraft damage reports document holes in wings or fuselage attributed to defensive fire. Repair logs detail patching and reinforcement work carried out between sorties. Radar-guided interception attempts were logged with particular detail. Control center logs record vector instructions issued, altitude changes ordered, and times of loss of contact. These logs sometimes include annotations such as target above ceiling. Such annotations were factual descriptors used by operators. Fighters receiving these vectors recorded compliance in their debriefings, noting altitudes reached. Night bombing operations intensified during this period. Night fighter squadron diaries record increased sortie counts. Equipment inventories list airborne interception radar sets with limited range and reliability. Maintenance logs for these sets show frequent calibration issues. Pilot reports from night sorties often note radar contact lost during climb or interference from ground clutter. Searchlight coordination records indicate continued attempts to support night interceptions. Logs include beam alignment data and communication attempts with fighter control. Many entries note brief illumination followed by loss of contact. These outcomes were recorded without further comment. Civilian observation networks remained active. Reports from these networks include time-stamped observations of bomber noise, flares, and explosions. These reports were aggregated at local headquarters and forwarded upward. Correlation tables attached to these reports compare civilian observations with radar and military logs. Loss and attrition continued to be documented. Aircraft loss reports list cause, location, and pilot status. Many losses during interception attempts are attributed to engine failure at altitude or fuel exhaustion. Personnel casualty reports follow standardized formats, listing names, units, and circumstances. Replacement flows are documented in personnel assignment orders. Command-level correspondence from this period includes repeated status updates on air defense effectiveness expressed in numerical terms. These updates list sortie counts and engagement rates. They do not include qualitative assessments. Requests for equipment and fuel are reiterated in these messages, with responses recorded as acknowledgments or revised allocations. As June 1945 progressed, air defense units operated under increasing frequency of alerts. Duty rosters show extended shifts for radar operators and control officers. Fatigue-related incidents are recorded in internal safety logs, including errors in plotting or communication. Corrective instructions were issued and logged. Operational documentation continued to be produced in large volume. Daily situation reports compiled by regional headquarters include summaries of radar contacts, sorties flown, engagements reported, and damage observed on the ground. These reports follow a consistent structure and are archived sequentially. The cumulative record from this period reflects continued execution of established procedures under evolving conditions. Each log entry, report, and directive captures specific actions taken at specific times, recorded according to wartime administrative practice. The narrative of events emerges from the chronological accumulation of these records, each contributing factual detail to the ongoing account of air defense operations as they were conducted. From late June 1945, Air Defense Headquarters continued to issue daily warning and scramble instructions through existing channels. The duty system at radar stations and fighter control centers remained in continuous operation, with shift schedules posted and signed. Radar logs from coastal and inland stations recorded frequent contacts approaching from multiple bearings, sometimes in streams, sometimes in discrete groups. Operators entered time, bearing, estimated range, and altitude estimate when available. When returns were weak or intermittent, the log entries often include short notations indicating signal fluctuation or uncertain altitude. Telephone and radio transmission logs at the stations record the times reports were sent to sector control and whether acknowledgement was received. At sector control centers, plotting officers continued to maintain track boards and written track sheets. These sheets show sequences of bearings and range estimates over time, with annotations for suspected target type based on speed and altitude. Scramble orders were issued according to the standing thresholds in local orders. The order books at fighter bases include entries showing the time of alarm, the aircraft assigned, and the takeoff times of each section. When takeoff did not occur, the reason was recorded in brief form, including runway damage, fuel restriction, aircraft unserviceability, or communication failure. Where aircraft launched, flight dispatch records list pilot name, aircraft number, armament load, fuel load, and assigned frequency. Aircraft maintenance sections continued to work within reduced supply and increased wear. Daily maintenance status boards were copied into logbooks. Entries list specific defects, including supercharger performance degradation, coolant leaks, spark plug fouling, magneto faults, oxygen regulator leakage, and canopy seal failure. Ground crews recorded the parts used and the source of parts when obtained through cannibalization. Inspection notes after high-altitude sorties commonly list the engine power setting used during climb and whether abnormal temperatures or pressures were observed. When engine changes were required, the engine number removed and the engine number installed were recorded, along with the hours on each engine if known. Fighter units continued to execute the climb and interception procedures specified in operational circulars. Pilots' debriefing forms include altitude reached, time to altitude, sighting information, estimated range at sighting, and whether an attack position was achieved. Many entries record sighting of contrails at high altitude without closing to firing range. When closing occurred, engagement reports list approach method, range at first firing, ammunition expended, and observed results such as smoke, pieces falling, or loss of visual contact. Reports also note evasive action taken in response to defensive fire and whether the pilot observed other friendly fighters near the target. When escort fighters were encountered, reports list aircraft type observed, altitude, and whether combat occurred. Ground-controlled interception procedures continued to be used where radar tracking permitted. Control center radio logs record the sequence of vector instructions, including heading changes, climb orders, and estimated target range. These logs show repeated instances of target altitude being revised upward after additional radar plots, requiring further climb orders. In such cases, pilots' debriefings often record reduced engine response and decreased climb rate at the revised altitude, with notes on oxygen flow and instrument readings. When radar contact was lost, control center logs record the time of loss and the last known bearing and range. Pilots' reports then record return to base, descent, and landing time, with fuel remaining noted. At airfields, dispersal and camouflage continued to shape daily operations. Base defense logs document alerts for incoming air attack and the movement of aircraft into revetments after landing. Taxiing restrictions imposed by damaged surfaces were recorded in operations notes. Where runways had been cratered, engineering units recorded repair work in daily summaries, listing the number of craters filled, materials used, and hours worked. These repairs were often followed by test runs recorded as brief entries stating that a given aircraft conducted a low-speed or high-speed run, or that a takeoff was executed to confirm usability. Fuel storage logs recorded distribution from available tanks, with losses noted when tanks were damaged or when fuel was contaminated by debris. Air Defense Headquarters continued to collect and collate civilian observation reports. Police posts, factory watch organizations, railway personnel, and civil defense observers submitted time-stamped observations of aircraft noise, contrails, flares, and explosions. These reports were compiled into local summaries with grid references or place names. The summaries were forwarded to regional headquarters and appended to daily situation reports. In many cases, these civilian reports recorded the passage of high-altitude aircraft without visible interception, and the reports include notes on the direction and duration of engine noise. Meteorological units continued to issue upper air bulletins. These bulletins listed wind speed and direction at multiple altitudes, temperature, pressure levels, and cloud layers. Fighter units recorded receipt of these bulletins in the duty log. On days with strong upper winds, pilots' debriefings record drift during climb and difficulty maintaining assigned headings. When cloud layers obscured contrails, reports record delayed visual acquisition. Icing conditions were also recorded in debriefings and in aircraft inspection notes, including ice on canopy frames and gun ports after descent. During daylight operations, bomber formations were recorded as approaching at varying altitudes depending on mission profile. Radar logs continued to list high-altitude tracks, while ground observers recorded formations at lower altitudes during later stages of some raids. Fighter units attempted to adapt by positioning aircraft on climb or patrol at intermediate altitudes when fuel and aircraft availability permitted. Patrol orders were recorded in unit operational notes and included assigned altitudes, sectors, and time on station. These patrols often ended due to fuel state, recorded in flight logs as time off station and landing fuel remaining. Night operations continued with increased sortie rates for assigned night fighter units. Unit diaries record the number of sorties launched, the number of radar contacts obtained, and whether visual contact was achieved. Night fighter equipment logs record the status of onboard radar sets where fitted, including calibration notes and antenna damage. Where night fighters relied on ground control and searchlights, coordination logs show repeated attempts to bring fighters under illuminated targets. Searchlight unit logs record beam elevation and azimuth changes, duration of illumination, and instances where the target moved beyond beam limits. Anti-aircraft unit firing logs recorded the times of firing, estimated target altitude, ammunition expenditure, and observed bursts. These logs were kept separately and later summarized in Air Defense Headquarters reports. Throughout late June and early July, operational directives continued to authorize alternative attack methods for targets at high altitude or beyond the ceiling of available fighters. These directives were issued as written circulars and recorded in the unit order books. Briefing notes attached to these circulars list prescribed approach angles, including head-on attacks and climbing attacks from below when possible. Some directives included instructions for closing distance rapidly and firing at short range. In unit diaries, briefings were noted by date and the names of officers conducting them. Subsequent engagement reports from sorties flown under these directives record approach attempts, range estimates, and outcomes. When a pilot attempted a head-on attack, reports record closing speed, time available for firing, and the pilot's breakaway direction. When a pilot attempted to maintain position behind a bomber formation, reports often record inability to remain in position due to reduced engine power at altitude and high fuel consumption. Ammunition supply was recorded in depot and unit logs. Inventory sheets list rounds by caliber and type. Some units recorded shortages of certain ammunition types and substitutions made. Gun harmonization and test firing records were maintained, showing dates and results. After sorties, ammunition expenditure was recorded in flight logs and cross-checked against armory ledgers. Weapon maintenance notes continued to record feed jams, misfires, and recoil-related damage. These issues were sometimes associated in the logs with high-altitude temperature conditions, noted as cold-related stiffness or lubricant thickening. Aircraft damage reports remained routine. When aircraft returned with damage forms recorded the location of holes, the estimated source as defensive fire or anti-aircraft fire, and whether damage affected control surfaces or fuel lines. Repair logs recorded patching work and replacement of components such as control cables or hydraulic lines. In cases of severe damage, the aircraft was listed as non-operational, and the status return noted the aircraft as under repair or written off. Where aircraft did not return, loss reports were filed listing last known position, last radio transmission if any, and whether the pilot was seen to bail out. These reports were forwarded through personnel channels and recorded in casualty lists. Fighter pilot medical monitoring continued. Medical officers recorded incidents of hypoxia, frostbite, and loss of consciousness. These records were submitted as medical reports with dates and pilot identification. Recommendations included equipment checks and restrictions on rapid climbs without proper oxygen flow. Oxygen equipment inspections were recorded with serial numbers where available. In cases where oxygen regulators failed, the faulty unit was tagged and recorded in maintenance logs, and replacement was attempted from available stocks. As July 1945 progressed, Air Defense Headquarters recorded that incoming tracks were frequently numerous and sustained. Radar station logs show long periods of continuous plotting. Operator duty logs record relief times and personnel rotations. Where radar stations experienced power interruptions, logs record the time of outage and restoration. Some stations recorded reliance on visual observers during outages. Observer networks recorded aircraft movement by sound and contrails when visible, with time stamps and compass bearings. These were transmitted by telephone or messenger, depending on local conditions, and were compiled into the daily air defense picture as best as possible. Fighter bases continued to function under intermittent air attack. Base defense logs record alarms, dispersal orders, and damage assessments. When runways were attacked, the number of serviceable takeoff paths was reduced, recorded in operations notes. In some cases, units shifted takeoff to alternate strips or employed shortened takeoff procedures. These changes were recorded in base operating instructions. Takeoff accidents were recorded in safety logs, listing cause, aircraft, pilot condition, and damage. Where accidents occurred during scramble, the time of accident and its impact on subsequent launches were noted. The flow of messages between regional air defense commands and central headquarters continued through encoded radio and telephone when lines were available. Message registers record outgoing situation reports, including numbers of contacts, sorties, and engagements. Replies often contained revised instructions, reallocation orders, or requests for clarification of specific reports. These exchanges were recorded as brief entries with message numbers and times. In parallel, intelligence sections continued to compile technical notes on the performance of interceptors at altitude. These notes included engine settings, climb rate measurements from sortie logs, and comparisons between aircraft types. They were distributed internally as memoranda. The memoranda list data points and observed issues without narrative beyond the recorded measurements. Some memoranda included notes from test flights where aircraft were flown to maximum altitude to record performance. Such test flights were recorded in flight logs and followed by maintenance inspections recorded in technical logs. Toward the end of July, air defense units recorded increased difficulty sustaining continuous interception attempts due to aircraft attrition and reduced fuel. Weekly strength returns showed declining numbers of serviceable aircraft in some units. The returns list aircraft by type and note those under repair, awaiting parts, or written off. Personnel returns show pilot strength and note those lost, injured, or transferred. Training flight records show minimal sorties dedicated to training, with most flights recorded as operational alerts or ferry flights to relocate aircraft from threatened fields. Relocation orders were recorded in unit order books. These orders listed departure dates, destination airfields, and aircraft to be moved. Ferry flight logs record takeoff and landing times and fuel used. Arrival reports at new fields list the condition of aircraft and any damage during transit. Establishment of operations at new fields required coordination with local base services, recorded in brief notes regarding fuel availability, ammunition storage, and runway condition. Throughout this period, the central recurring entry across multiple forms remained the timing difference between bomber passage and fighter altitude attainment. Radar logs show tracks at consistent high altitude for certain missions, while fighter debriefings record maximum altitudes reached and time to reach them. The resulting mismatch was recorded as target above or no contact in many cases. When contact occurred, engagement reports detail brief firing opportunities and rapid disengagement due to closure speed, defensive fire, or fuel limitation. The administrative structure of reporting remained consistent. After each alert, individual pilot debriefings were compiled into unit summaries. These summaries were forwarded to group or regional headquarters. Regional headquarters compiled daily situation reports, including radar contacts, sorties launched, engagements, and ground damage reports. These reports were archived in chronological order, with attached appendices including meteorological bulletins, civilian observation summaries, and maintenance status returns. The record for late June and July thus continued to accumulate as a sequence of timed entries, procedures executed, and outcomes recorded in the terminology of wartime air defense documentation. From early August 1945, air defense organizations continued to operate under the same reporting and scramble procedures, with daily alert schedules posted and recorded at radar stations, control centers, and fighter bases. Radar logs show repeated detections of inbound tracks, with entries recording bearing, range, and estimated altitude where possible. Operator notes include intermittent signal quality and occasional loss of contact. Where radar coverage was reduced by equipment outages or damage, observer networks provided supplementary reports based on sound, contrails, and visual sightings. These observer reports were time-stamped, assigned location identifiers, and forwarded to local headquarters for compilation. At sector control centers, plotting continued on track boards and written sheets. The plotting records list sequential estimates of target position, with annotations indicating suspected bomber groups when speed and altitude matched previously observed patterns. Scramble orders were issued when contact reports met local criteria. Base order books record the times alarms were received and the aircraft assigned. Dispatch records list aircraft numbers, pilot names, fuel load, and armament. Where launches did not occur, log entries state reasons in brief form, including lack of serviceable aircraft, runway condition, fuel restriction, or communication delay. Fighter unit readiness reports continued to show reduced serviceability. Maintenance logs from this period include frequent entries for engine faults, supercharger performance issues, coolant leaks, and electrical failures. Oxygen system maintenance remained a recurring item, with records noting regulator leakage, hose defects, and mask seal problems. Repairs were recorded with parts used and whether parts were obtained from stock or through cannibalization. Aircraft inspection sheets after high-altitude sorties include engine temperature and pressure readings reported by pilots and checked by ground crews. Pilots' flight logs and debriefings continued to record climb times and maximum altitudes reached. Many entries note sustained full-power climb and decreasing climb rate above specified altitude bands. Fuel remaining at landing was recorded, often showing limited reserves. Where aircraft reached assigned altitudes, debriefings record sighting of contrails or distant formations. Engagement reports list approach methods and whether firing occurred, with ammunition expenditure recorded. Where no contact was made, forms record no visual, lost contact, or target above, using standardized phrasing. Ground-controlled interception logs show continued vectoring attempts when radar tracking permitted. Radio logs record headings, climb orders, and estimated range calls. In some cases, logs record the target altitude being revised upward during the interception sequence. Pilot debriefings corresponding to these vectors record attempts to comply, with notes on engine response and oxygen flow. When radar contact was lost, control center logs record time of loss and last known bearing and range. Pilots' reports then record return to base and landing details. Airfield operations were repeatedly affected by air attack and damage. Engineering logs record runway repair work, listing crater fill, surface leveling, and use of mats where available. Operations notes include restrictions on takeoff weight and taxi routes due to damaged surfaces. Base defense logs record alarms, dispersal actions, and damage assessments. Fuel storage records show distribution from remaining stocks, with losses noted when storage was damaged or when fuel was contaminated. Night operations continued where units remained capable. Night fighter diaries record sortie counts, radar contacts if obtained, and visual contact attempts. Equipment logs for airborne interception radar sets note calibration problems and repair efforts. Searchlight unit logs record beam elevation, azimuth changes, and duration of illumination attempts. Anti-aircraft firing logs record firing times, estimated altitude, and ammunition expenditure. These logs were compiled into daily air defense summaries with time correlations. Civilian and local authority reports continued to be collected. These reports include observations of aircraft noise, contrails, flares, and explosions, with times and locations recorded. They were aggregated by local headquarters and forwarded to regional commands. Correlation tables attached to some reports compare civilian observations with radar and military logs. During this period, command message registers show routine transmission of daily situation reports. These reports list radar contacts, sorties launched, engagements reported, and damage observed on the ground. Requests for fuel, spare parts, and replacement aircraft continued to appear in message traffic. Responses were recorded as acknowledgments or allocation directives. Personnel rosters and casualty lists continued to be updated with losses from combat, accidents, and operational strain. On August 6, 1945, air defense logs and civil defense records from Western Japan include entries indicating an air raid warning sequence and subsequent reports of an explosion and widespread damage in Hiroshima. The records include time stamps, initial aircraft detection reports were available, and communications among local authorities. Subsequent reports compiled by military and civil agencies recorded destruction in the city and disruption of communications. These entries were collected as part of routine reporting channels, with notations of interrupted lines and delayed messages. After August 6, air defense units continued to receive alerts and compile reports. Radar station logs show intermittent contacts, and observer reports continued to note aircraft movement. Fighter sorties were recorded where launched, with the same debriefing formats. Maintenance and fuel logs continued to document constraints. On August 9, 1945, records from Kyushu and surrounding regions include air raid warnings and subsequent reports of an explosion and severe damage in Nagasaki. As with earlier records, entries include time stamps, reports of aircraft presence, and subsequent damage reports compiled by local authorities. Communication logs record disruptions and delays in transmitting detailed information. Throughout the days that followed, regional headquarters continued to compile daily situation reports. These reports include air raid warnings issued, contacts detected, sorties launched, and ground damage reports. Where communications failed, reports note gaps and reliance on messenger delivery. Unit diaries and message registers record continued administrative activity, including aircraft relocation orders and dispersal instructions as airfields remain threatened. On August 15, 1945, Japanese military communications and unit logs record the receipt of orders concerning cessation of hostilities. Entries in unit diaries and order books note the transmission of these directives through command channels. Flight logs from some units record reduced or halted operational sorties following receipt of orders. Maintenance logs continue briefly with entries for securing equipment and accounting for aircraft status. In the subsequent days, Air Defense administrative records show continued compilation of inventories and status returns. Aircraft strength reports list remaining serviceable aircraft, those under repair, and those written off. Ammunition and fuel inventories were recorded by depot and unit staff. Personnel rosters were updated to reflect unit strength and losses. Communications logs include instructions for preservation of documents and equipment. The record of the period remains composed of timed entries and procedural documentation. Radar logs, observer reports, scramble orders, flight dispatch records, pilot debriefings, maintenance logs, fuel allocation sheets, and daily situation summaries continue to present events as recorded at the time, with details limited to observed actions, transmitted messages, and recorded outcomes.